Hi, my name is David Maletich, and today we're going to talk about corkscrews. Specifically, we're not talking about this and how it changes the way a fan performs, but rather how offset 90-degree elbows alter the performance of a fan. Let's talk a little bit about safety. Even though we're not at a job site, not at a factory, again, we want to make sure that we're practicing safe habits with our fan. On-off switches are not a reliable way of making sure that the fan is disengaged when we want to work on it. So make sure it's either locked out, tagged out, or unplugged from an electrical source before you start work. Thanks. Let's talk a little bit about the equipment required for the demonstration. We have a fan blowing into a rectangular round transition, round piece of ductwork that includes a pitot tube, some tubing that goes to this magnehelic gauge. We have a damper at the discharge, and that damper is preset at about 1 inch of water gauge or 250 Pascal, and that's going to be our baseline resistance setting. We have a nice little stand here to support this round piece of ductwork so it doesn't topple over while we're doing our demo, and we have two 90-degree elbows to create our corkscrew. Thanks, and on to the demonstration. Live demonstration time. Well, we have two 90-degree elbows, just straight 90-degree elbows, nothing inside of them, no turning vanes, no obstructions. And we're going to sit there and connect them in a corkscrew effect that's going to either pre-spin or counterspin the air as it enters the fan. And when we talk about that, we're talking about whether it's rotating air in the same direction as wheel rotation is or against the wheel rotation. Wheels rotate in the same way the volute shape of the housing expands. So I drew this nice little arrow here to show the wheel rotation, and we're going to simply see first how a fan is affected by counterspinning the air. Like our earlier videos, putting a 90-degree elbow decreases fan performance, and now we're going to counterspin the air and see what changes. Notice a couple things. When we look at the magnehelic gauge, performance actually increased. So a lot of times people think, hey, this actually makes the fan run better. Why don't we do this more often? You also notice that sound increased as well. We're counterspinning the air as it enters the fan. So it's like an airplane wing taking off into a strong headwind. While we've increased lift or the ability of that wheel to move the air, we've also created turbulence, and that turbulence results in increased sound as well as decreased fan efficiency. So the fan actually consumes more energy during operation. We can rotate this 90 degrees. And now we are pre-spinning the air into the fan. And you'll notice a couple things. One is flow pressure went down pretty substantially. Also, sound went down as well. And that's because we're now rotating the air in the same direction as the wheel is rotating, and that results in decreased performance. So that's similar to that same airplane taking off with a tailwind. The wing's ability to generate lift decreases pretty substantially. However, turbulent flow over that wing also decreases, resulting in lower sound levels. Now we're going to look at, do these vortex effects change over straight runs of ductwork? So we're going to take a little break, set things up, and move on to the next section of our presentation. Thank you. On to the second part of our demo. What we've introduced, straight run of ductwork, and we're going to see if that affects or changes the way the fan performs with a pre-spin corkscrew. So put this on top of the, or put this onto the inlet. Again, this is our 90-degree elbow here. No vanes, just a 90-degree elbow. And we're going to put this second elbow on in the pre-spin configuration. Notice during performance that despite this run of ductwork, that the pre-spin elbow configuration is almost the same exact performance as what it was when we had this at the fan inlet. And we'll talk about that in our final thoughts. Final thoughts on corkscrews. As you can see, corkscrew ductwork does affect the way a fan performs. If you counterspin the air, you'll have much better performance than if you pre-spin the air. However, counterspinning the air. We just have to make sure that we compensate for that with a little bit of a safety factor on energy consumption, because we are going to consume more energy. Straight runs of ductwork, while they typically save or help with fan performance, don't really work very well on circular flow patterns. So if we create a vortex going through the duct, air's going in a circular pattern, we have to remember that the fan wheel is also creating a vortex as well. Not quite as strong as this one, but it is creating one. And as a result, it can carry vortexes through duct for very extended periods of time. I've seen them carry as long as 300 feet. Only way to break that up, put some kind of straightening vanes or splitter vanes inside the duct to help break that vortex, or to use some kind of diffuser in the duct, and that's effective as well. Any questions, comments, put it in the section below. We'll get right back to you. Any videos you'd like to see us produce in the future, let us know as well. Thanks a lot.